Hi, my name is Matt Buffington. I'm a research entomologist with the Systematic Entomology Lab at the USDA. I work on parasitoid Hymenoptera, the taxonomy, biology, behavior, and I'm going to demonstrate to you one of the primary collecting techniques we utilize to obtain specimens of parasitic Hymenoptera, and that is the yellow pan trap. It's effectively a small bowl, typically one you would use at a picnic for, say, ice cream, filled with water and a little bit of detergent, typically biodegradable detergent, and we set these out in sunny areas on the ground amidst the vegetation in that particular habitat. Insects, particularly parasitoid Hymenoptera, for reasons we do not understand completely, seem to be attracted to this particular color yellow. When they're attracted to it, they fly towards it and they enter the water. Because we've added a small bit of detergent to the water, the surface tension is effectively zero and the insects fall in and drown. And you can leave these things out for upwards of 2-3 days at a time until the water evaporates. People put pan traps out for various lengths of time. Some people like them only out for 24 hours, some people just for 8 hours, some people out for a few days. It really depends on a couple things. How quickly is the water evaporating? How difficult is the collection site to get to? And how long are you willing to allow specimens to sit in the soapy water? If you're after specimens for DNA work, the soapy water can be quite detrimental to their DNA, at least given current DNA extraction and amplification techniques. That may change in the future, but right now the soapy water doesn't do well for DNA. Personally, I like to pan trap relatively close by where I might be camping or a field station where I might be working, and I like to service them daily. This allows me two things. One, the specimens are really fresh, and that's best for the kind of work I'm doing. Second, it lets me look at the pan traps and see, are they doing anything? Are they collecting anything? Especially if I have a lab nearby, I could actually begin sorting, and if there's something in particular I'm after and I'm getting large numbers, and there's another site nearby where I've got pans out and there's nothing going on there, I might move all the pan traps into one site to maximize the catch. The tools for this type of collecting are extremely simple. It starts with the pan. These are made by Solo Cup and Cup Bowl Company. I don't know what it's really called. They come from the grocery store. Sometimes the right color yellow is not easily obtainable, but you can contact Solo directly and order them directly from them. You can also buy white ones and paint them. Fluorescent yellow paint actually works extremely well, and from our basic statistical analyses, there's no significant difference between this plain yellow and fluorescent yellow, so that's always a good solution. The other very key element you need is a small net you would use for a home aquarium, but it's not a normal one. These we call the Brine Shrimp Net. They're used by people that raise brine shrimp as feed for their fish, so the mesh is super fine. If you use a regular fish net from the pet store, you'll be able to catch things like bees, beetles, larger things that might be in pan traps, because they do collect everything. But you'll miss a lot of the tiny parasitoid wasps, tiny flies, tiny beetles. They'll go right through the mesh. So you got to make sure you get the right size mesh. The last thing you need, which is a critical component, if I can remember what pocket I keep them in, are Whirl-Pack bags. A Ziploc bag will also work. What you want to be able to do is, after you've poured your sample through the net, which I'll show you in a minute, this sample becomes extremely valuable with each additional sample you pour through it as you accumulate specimens. And you want to take this to a place where you can wash that soapy water off and transfer the specimens to ethanol or propylene glycol or any other preservative. And you need a Whirl-Pack in order to get this collection event safely back to the laboratory. Or a Ziploc bag. It's some type of bag that you can put the whole net into full of insects. So now I'm going to demonstrate how we get the sample out of the bowl and into the net. In this case, I have 2 pans. You can have up to 200 if you want in a transect. It's really up to you how many bowls you're willing to carry around with you and how much water you're willing to carry to fill them. The technique I'm about to demonstrate does three things actually. One, it gets the insects into the shrimp net so we can use them later on. Second, we're going to prevent the soapy water from going into the environment. And third, we're going to conserve the soapy water so we can reuse it so we don't have to constantly be refilling these things over and over again. So basically, I've got two pans here. One is fairly low, the other one has a little bit more. I'm going to pour this pan through the net and then catch all the water in this pan. Then I'm going to reverse the process. That way we'll get all the insects out and we'll save the water. I always give it a nice swirl at the end to make sure everything's up and is suspended. And that's the material from just 2 pans in 24 hours. It's quite remarkable how much material you can get. Multiply this by 200 pans and you've got an entire ball of solid insects. Very little plant material, very little garbage, pure insects. Okay, now that I have the sample in this brine shrimp net, it's covered in soapy water. Those specimens are not happy at the moment, and we're going to have to wash these off. However, we're in the field right now, and I don't have the tools with me in order to effectively wash all the soapy water off and transfer them to a more stable preservative for the insects. This is one of the single most important aspects of pan trapping that will either yield a successful sample or a sample of less scientific importance. What we call a damaged sample, or maybe one we'll even throw away. These specimens cannot dry out at this stage if you don't have the means in order to wash them at the moment. And this is where the Whirl Pack comes in. If you've never used a Whirl Pack before, open it that way, open it up, twist the bolus inside the net thusly, so they don't spill out. And then you slide the whole net, twist it up inside the bag. Just like that. This will keep it moist enough until you get back to the lab and can finish processing it. Okay, now that we've serviced the traps, we can replace them in the field. Placing the trap is actually very critical and can be used for a variety of purposes. If you're actually after a specific habitat, you can get pan traps actually quite close and intimate with those habitats. You might be doing some sort of survey of a particular host plant and put all your pans near that host plant. You might run a transect if you want to do something that is comparative in a statistical framework. It's really up to you. One of my colleagues in the lab really likes parasitoids of wood-boring beetles. So I often find wood in the environment, and I like to put pan traps near them, and with the hopes of actually capturing some of these wasps. In the pans I've already sampled and processed and put into the net, I actually saw these wasps in there. So I know I'm in a nice hot spot right here for those particular wasps. So I've got the 2 that I've already serviced, and this is typically how I try to find a place, try to nestle it in so it's nice and secure, and then from the other pan, filled up about halfway. I often fill the pans just halfway in an environment such as this. We're currently in the southeastern United States in spring, where we get almost daily rain showers. If you fill them up too much, they'll overfill when it rains. If you give them some room, they can actually take quite a bit of rain before they overfill, and then you don't lose your sample. In a desert ecosystem, for instance, I fill them all the way to the top because in about 24 hours they'll be completely dry if you don't service them regularly. So it kind of depends on where you are. Some people add salt to the solution to decrease the rate of evaporation. There's all kinds of little tricks you can do. But in this case, where we are, I fill them halfway. And I've nestled it now adjacent to some of this wood. There's some kind of mud down here. I'm happy with that. These are all things that are attractive to a variety of insects and their parasitoids. There's also some little flowers in here, and that's what actually attracted me to the site in the first place. So I'm actually going to place the other one amongst those flowers.